So in the last video, we talked about a lot of the designs we had and what our plans for. We were going to build this rocket. Here's the kind of rocket we were going to build. What's it going to be like? So now here we are. We built the rocket. In the second phase of Project Firefly, we've been working on the final construction and testing of our rocket.
What we actually ended up testing was a series of static fires with the valve changing and the tube remaining constant at the 1/8 macroline tubing, and just trying to find a valve that would give us the amount of thrust we needed.
So we're talking a lot about rockets, but really the crux of a rocket of this size and of this level of simplicity is what kind of tank you're using and what kind of valve. So it's not really so much the type, but it's what really those are. How big are they? How much do they weigh? It's really about how light can you move.
We started off doing our static fire test of the propulsion system. We hooked up a load cell to the thruster and put it in the rocket pit. So the first test we did, we got virtually not measurable thrust and ended up discovering that some of the specs of our valve that we had chosen were not what we thought they were.
Our first valve produced about 1 pound of thrust, and that was, ideal conditions.
We found that the differential pressure across it, which is the pressure drop in that valve, was a lot greater than what we were expecting.
The valve was really just too small. We had been using some really tiny steel tubing that was constricting the flow too much, so we needed to find a different valve option.
Switching the valve to a different valve, we got about 5 pounds, but again, we're really looking for that 6 pounds minimum in order to really get our rocket off the ground.
We eventually got to our full system test, which was great. We actually had the fully assembled system in the pit.
We had the rocket set up bare bones in order to reduce the weight. We did get some movement on the platform, but it wasn't until that we were able to remove the tank and remotely fuel the system that we were able to see liftoff and hovering. It did seem to reach the required height, but it did not hover for 5 seconds. It hovered and just fell as the thrust slowly decreased as the tank got really cold.
We discovered that it cooled off way too fast, so we couldn't sustain our thrust over the whole flight profile. You lose temperature, you lose pressure, you lose thrust.
Our estimates show that the tank probably got to almost negative 200 Fahrenheit in that moment of testing.
So what we found there is we needed a redesign. So that's what comes next. And that's often how engineering works. You design something, you model it to the best of your ability, you can do all the calculation you want, but sometimes real hardware just doesn't work like the computer says it does. Real hardware is a little different.
In order to fix the problems that we're currently facing right now would be to look at either an alternative fuel source or a tank that has less fuel in it. Because right now, with how much fuel we have, we're only using the 10 seconds burn of it. So with a smaller tank, even though the weight reduction would be minimal, we have a lot of fuel that we're not even utilizing to its fuel potential. Another thing something that could be changed in order to help the system would also be the valve. The valve for Project Firefly right now is the crux. If moving forward we can find a valve that can handle the pressure we need and it's light enough to fit easily in our system, that's going to be the key to getting our rocket working.
The next biggest issue we had to deal with was the temperature drop in the tank. Our plan to continue would be to find a way to heat the flow before it goes through the nozzle so that it doesn't cool off so fast and we could actually sustain the much higher thrust that we saw at the beginning of the flight.